identities is you have to get out of your head. These are not equations that you're solving. So all those properties of equality, adding, subtracting, multiplying, dividing to both sides, are out the window. We're not solving anything. You're going to see an equal sign, but you're not solving it. When we talk about an identity, what we're talking about is a relationship that can be expressed as some formula or some other function. An identity is an equation that is true for all values of the variable for which every term of the equation is defined. Now, just some notation thing that's come up. When you see a trig function raised to a higher power, so for example, when you see the sine of x squared, it's equal to sine squared x. Some mathematician along the way, I guess, got lazy and got sick and tired of writing parentheses. So they decided, you know what, instead of writing parentheses sine of x to the second power, I'm just going to write as sine squared of x. It does not mean sine of x squared. In other words, it does not mean that the x is being squared. You're going to be proving, so when I ask you to prove or simplify an identity, the objective is to simplify just one side to mirror the other side of the equation. And this is where some of you will get into trouble because you're not going to listen to a word I say and miss the whole objective of this. You're only going to work on one side. Properties of equality do not apply. So you're only going to work on one side. You do not treat the, yeah, Philip. Just prove, I'm sorry. I put an extra there. Just prove, sorry. When prove or simplify. Do not treat identities like an equation. That's what you guys have to understand. These are not equations. You may not add, subtract, multiply, or divide to both sides of the equation. Properties of equality do not apply. We're not solving anything. You may not cross multiply. So nothing with solving equations works. What you're going to do is you're going to pick a side of the equation and you're going to stick this side. By substitution, algebra, the goal is you take one side of your equal sign and you want it to come up with what's on the other side through manipulation. And that's what we're going to practice. I basically just went over all of these on your pink formula sheet. So all these are on your pink formula sheet. I just thought because they're in the notes, but you're going to be referring to this pink sheet quite a bit. It's just more helpful to have this on a separate sheet of paper. All right. So let's talk a little bit about what we're going to do. So before we get into proving identities, let's just try and simplify. So when I ask you to simplify, the goal is to try and get it in terms of one trig function. A lot of times, a strategy that you're going to try is changing a lot of things into sine and cosines. So take a look at tangent times cosine. Is there a way to change tangent, looking on your pink formula sheet, is there a way to change tangent into a sine and a cosine? Yes, what's tangent equal to? Sine over cosine. So sine x, so what I'm going to do is I'm going to rewrite this. Tangent of x is sine over cosine x times cosine x. What's the denominator, by the way, for cosine x? 1. So when I multiply fractions, remind me again, what can I cross cancel? I can cross cancel the what? The cosines. And then what am I left with? Sine of x. And there you go, you've just simplified it. So a lot of times when you're proving or you're simplifying, one strategy that comes up a lot is to change everything into sines and cosines. The thing is, guys, this is where some of you that like to do a lot of work in your head, this is where you're going to struggle. Your work is your answer. In other words, step by step, showing me how you get from one thing to the next is your work. So let's take a look at B. We have cosecant times tangent. So let's try changing everything into sine and cosine. What is cosecant equal to? Looking on your sheet, is there a way to change cosecant into a sine or a cosine? Yes, what's cosecant equal to? 1 over sine. So I can write this as 1 over sine x. Times. We just talked about what's tangent equal to. Tangent's equal to what? Sine over cosine. And then what can you cross multiply? You can cross multiply what? Sine. So what am I left with? 1 over cosine. Typically, in most cases, you never want to leave a fraction as an answer to be in completely simplified form. What is 1 over cosine x equal to without a fraction? 1 over cosine x is equal to what? Secant x. So again, the idea is, the objective is, if you can, write it in terms of one trig function and without a fraction. You guys go ahead and try C for me. All right? Again, what we're trying to do, we're trying to take an expression that has more than one trig function in it, and our goal is to try and rewrite it in terms of one trig function if possible. All right, that's the goal, without a fraction as the answer. All right, so we should have come up with cosine x. You guys go ahead and try D for me. I'm sorry? You change cotangent into cosine over sine. Like I said, if you are stuck and you don't know where to start, always try changing things into sine and cosine. All right? We know cotangent is equal to cosine over sine. Brendan, question? Because cotangent, if you look on your pink sheet, cotangent, remember, is cosine over sine. All right? So look at D. We have sine x times. Now what is secant equal to? Looking on your pink sheet, try changing everything into sine and cosine. 1 over cosine. Again, I'm multiplying. So I'm just going to multiply straight across. That's going to give you sine x over cosine x. Remember, the goal is to try and rewrite this in terms of one trig function. What is sine over cosine equal to? Tangent of x. So let's look at E. Again, we have cotangent times secant. Try changing everything into sine and cosine. What is cotangent equal to? Cotangent's equal to what in terms of sine and cosine? Cosine of x over sine x. Times. What's secant of x equal to? In terms of sine and cosine. Looking at your pink sheet, 1 over cosine. And then what can you cross cancel? You can cross cancel the what? Cosines. So what am I left with? 1 over sine x. Don't leave a fraction as part of your answer. What is 1 over sine x equal to? Cosecant x. So like I said, the strategy we're trying to do here, try changing everything into sine and cosine. That's a big strategy that we're going to use to help us get started on some of these. If you don't know what to do or don't know where to get started, try changing everything into sines and cosines. Again, the quicker you know the pink sheets, the quicker these are going to go for you. All right? So given sine of x is equal to 0.28 and cosine of x is equal to 0.96, let's find cosecant of x. Well, what's cosecant of x equal to? Cosecant of x is equal to 1 over sine x. So they're telling you that sine x is equal to 0.28. Then cosecant of x is just going to be equal to 1 over 0.28. You guys go ahead and tell me what secant of x is equal to. I hope we got 1 over 0.96. Okay. All right. So any questions, guys? So this was just some practice really dealing with your reciprocal identities along with the quotient identities. And again, just trying to change everything into sine and cosine. Now let's talk about this middle part of your pink sheet. That's your Pythagorean identities. The Pythagorean identities come from your unit circle. Remember we did back in Unit 1, we were drawing these triangles in our coordinate plane. And remember we had this point, and I labeled the horizontal side of my triangle X, the vertical side Y. And in the unit circle, remind me again, the hypotenuse of my triangle was equal to what? 1. So then we call these Pythagorean identities for a reason. Looking at this triangle, what is the Pythagorean theorem? The Pythagorean theorem would be what? X squared plus y squared equals 1. We'll get down to that. Don't worry about that for a minute. Pay attention to my triangle I'm drawing. So you agree with me by my Pythagorean theorem, x squared plus y squared equals 1. So remind me again, what trig function is x equal to? X is equal to what? Cosine. Y is equal to sine. So that's where this Pythagorean identity comes from. Sine squared plus cosine squared equals 1. It comes from that unit circle. Okay? Yes. So, this Pythagorean identity, sine squared plus cosine squared x equals 1. That's the major Pythagorean identity. If you know this one, you can find all the others. And most of you, because we've been working on that unit circle so much, and you know that x is cosine and y is sine, you're going to remember sine squared plus cosine squared equals 1. If you know that one, you're going to know the rest of them. Yes?
What does that say?
I'm getting to it. So again, we use this to derive the other two identities. If you can remember sine squared plus cosine squared equals 1, you can come up with all the others. All right? The way we come up with the others is let's take sine squared x plus cosine squared x, and let's divide everything by cosine squared. Sine squared divided by cosine squared. Well, what's sine over cosine equal to? Tangent. So sine squared over cosine squared is going to be equal to tangent squared x. Plus, what's cosine squared divided by a cosine squared? 1. 1 over cosine from my pink sheet was equal to what? Secant. So this is going to be my secant squared x. There's my second Pythagorean identity on my pink sheet. 1 plus tangent squared is secant squared. So like I said, if you know sine squared plus cosine squared, you can come up with the others if you ever forget them. So the second one, like I said, is your tangent squared x plus 1 is equal to secant squared x. This is the big one you want to remember. If you can remember this one, then you can come up with the others. That's the big one you want to remember. I'm sorry? Well, remember I divided this one by cosine squared. Guess what I'm going to take my big one and divide it by sine squared. Well, again, what's sine squared divided by a sine squared? 1. Cosine squared divided by a sine squared would be a cotangent squared x. 1 over sine is equal to what? Cosecant. And this would be cosecant squared x. And there's that third one. The 1 plus cotangent squared equals cosecant squared. Either way. It's just, again, some people, most of you by the end of this unit are going to know sine squared plus cosine squared equals 1. It's going to be second nature to you. Some of you will have these memorized, so you won't need to worry about it. Some of you may forget what these other versions are, so I'm showing you can always get the other versions by dividing everything by a cosine squared, dividing everything by a sine squared. So if you ever forget them, you know how to come up with them. Okay? Again, you can use other forms. or your pink sheet calls them the alternate forms. So if you remember sine squared plus cosine squared equals 1, you can solve for sine squared by subtracting cosine squared on both sides. That's what they mean by the alternate forms. You can algebraically manipulate this. You can solve for cosine squared by subtracting a sine squared. All right? So when we're doing these identities, the strategies we've talked about is we try changing things into sine or cosine. That's what we practiced doing a few minutes ago. We do not want any fractions in a solution. That's where we use those reciprocal identities. How do you know when to use these Pythagorean identities? Anytime you see something squared, a trig function squared, zero in on those Pythagorean identities. So that's when you know, because the question is, where do I get started? If you see something squared, that's where you want to zero in on those Pythagorean identities. So the strategies we want to try, changing everything into sine and cosine. No fractions in your final answer if possible. Use your Pythagorean identities when you see something squared. That's kind of a jump start. This hexagon may help some of you memorizing the Pythagorean identities. How many sides to a hexagon? 6. How many trig functions do we have? 6. So the way the hexagon works, like I said, some of you will straight memorize. Some of you will find this visual tool helpful to memorize these Pythagorean identities, or for you to see what the Pythagorean identities are. So I have a hexagon drawn here with a 1 in the middle. So from this 1, I've drawn a vertex, a segment from the center to each vertex in the hexagon. What I'm going to do is I'm going to label. Starting at the top, I'm going to label sine and cosine. I'm going to move counterclockwise around, putting my trig functions in alphabetical order. So after cosine will come a cotangent. After cotangent will come a cosecant. Then I've got secant. Then I've got tangent. So we start by labeling the vertices of the hexagon. So I always start sine and cosine at the top. The other 4 we work counterclockwise and we put them alphabetically. Notice only every other triangle is shaded. I only work around the shaded triangles. So in the first triangle at the top, I have my sine and I have my cosine. So if I take sine squared x and I go across this top triangle, sine squared plus cosine squared, notice when I go down in my vertice of down my hexagon, it gives me a 1. There's that first Pythagorean identity. Sine squared plus cosine squared, when you go down, that's what it's equal to. Notice my second shaded triangle. When you go across, you add. So 1 plus cotangent squared equals cosecant squared. So 1 plus cotangent squared equals cosecant squared. That's the second triangle from the hexagon. Like I said, some of you are more visual. It'll take you 10 seconds to sketch a hexagon in the corner of your paper, and you'll learn how to manipulate around this hexagon. Sorry, what was your question?
Are they all squared?
Yes, because we're dealing with the Pythagorean identities, yes. So now looking at the darker shaded triangle.
Why would it be 3 of
So looking at your third one. When you go across the triangles, you add. So tangent squared plus 1 equals that third vertice of secant. So then tangent squared plus 1 equals secant squared. These also can be used to help you find the alternate forms of your Pythagorean identities. Going back to your hexagon, instead of adding when I go across, I'm going to start at the bottom of each triangle. When you start at the bottom and you go up, you subtract. 1 minus sine squared is equal to that third vertice. So 1 minus sine squared is cosine squared. You can go up the other side. 1 minus cosine squared equals sine squared. So notice sine squared is equal to 1 minus cosine squared. Cosine squared is equal to 1 minus sine squared. So just remember, when you work around the hexagon, when you go across the top of the triangles, you add. So sine squared plus cosine squared is equal to that third vertice. Or if you start at the bottom and you go up, you subtract. 1 minus sine squared is cosine squared. Yep. 1 minus cosine squared would be equal to that third vertice. And 1 minus sine squared is equal to that. Helps you with those alternate forms. You don't have to remember. The goal is, let's not memorize more than what we need to. If you understand the hexagon, then you're not going to, all you have to do is remember how to work the triangles in the hexagon and how to label it. So looking at your second shaded triangle, remember 1 plus cotangent squared is cosecant squared. So you can go across when I add, but instead of going across, start at the bottom. When you start at the bottom, you don't add, you're going to do what? Subtract. So cosecant squared minus cotangent squared would be equal to 1. Or cosecant squared minus 1. If you start at the bottom and go up, you subtract. You never go down. You go across, or you start at the bottom and you go up. You never start by going down. That was my 1 plus cotangent squared is equal to cosecant squared. You always start going across, or you start at the bottom and you go up. Okay? Those are the only directions you're allowed to start in. All right? So then at the bottom, remember cosecant squared minus cotangent squared is equal to 1. And then cosecant squared minus 1 is a cotangent squared x. Again, you can only work around the shaded triangles. That's it. Don't work around any of the white triangles that are not shaded in the hexagon. So again, like we did the last one, tangent squared plus 1 is secant squared. Start at the bottom and go up. Secant squared minus tangent squared is 1. Secant squared minus 1 is tangent squared. So those are your alternative forms down there. Again, remember, when you go up, you subtract. When you start at the bottom and you go up, you subtract. Well, it's just helping you. So again, you don't want to have to memorize 9 different formulas if you don't have to. So if you understand the hexagon, you have less to memorize. Some of you may not find this helpful. Some of you will. I always sketch it. I know sine squared plus cosine squared equals 1, and I know the other 2 primary ones, but I don't want to constantly algebraically manipulate them all the time. It's less to memorize. All right. So now let's just do some more practice with these. Remember, when proving identities, the objective is to simplify one side to mirror the other side of the equation. Never move to the other side of the equal sign, or never move, or never work to the other side of the equal sign. You pick a side and you stick to it. And the strategy is you're going to end up picking the more complicated side. Some of you are not going to listen to me. And you're not going to be very happy when you see your first quiz. Because you're going to start manipulating things on both sides of the equation, and I'm going to give you absolutely no credit. And you're going to try and argue with me. You are not working with equations. No properties of equality apply. Mila, did you hear that? So if you start working on both sides, there is no credit on a quiz or a test. You pick a side and you stick to it. So let's take a look at the first one. What appears to be the more complicated side of the equation? Left side. So this is a side I'm going to work on, and I'm going to stick to it. And I usually just kind of draw a line to remind me that I'm not going to work on both sides. The goal is to take this more complicated side, and what you want to do is you want to break it down so that this left side can be rewritten as a secant. So it's a little different than the problems we did before where you had no idea what the end goal was. Now you do. The goal is to get this left-hand side in terms of a secant. So let's take a look. You got a cosine, and you got a 1 plus tangent squared. Anytime you see a 1 and a trig function squared, guess where I'm going to look on my pink sheet? I'm going to look under my Pythagorean identities. Anytime I see a trig function squared, I go to my Pythagorean identities or look at your hexagon. What is 1 plus tangent squared equal to? Secant squared. So my first step is I'm going to rewrite this as a cosine x times a secant squared x. You must give me a justification. What rule or what theorem did I use? I used my Pythagorean identities. It's like a proof in geometry. I know it's your favorite, but you've got to give me a reason of what you did. So now, what we just practiced a few minutes ago, try changing everything into sine and cosine. I do have a cosine. How can I change secant squared into a cosine? What is secant squared equal to? 1 over cosine. So I have cosine x times 1 over cosine squared x. And again, that's your reciprocal identity. I can multiply, can't I? And what's going to cross cancel? The cosines. So what am I going to be left with? 1 over what? Cosine x. And all I did here, I didn't do any, I just multiplied. So some of the reasons is just going to be you multiplied. Where am I trying to get to? Take a look at the end goal. What's my end goal? I'm trying to get it in terms of a what? Secant. So I'm almost there. So 1 over cosine, what is 1 over cosine equal to? Secant. So the fourth step is it's going to be a secant x, and that's just my reciprocal identity. If I look at your paper and I have to ask you how you went from here to here, you are doing too much in your head. There is no work in your head. A good way to check to see if you're doing these is show it to your friend. And if your friend has to ask you, how did you go from here to here, you know you're missing a step. And you're missing a reason. All right? I should be able to read this step by step and not have to ask you that question. All right? You've got to write out every single step. Yes, Chad? Yes. And your homework, yes. So if you give me a homework with no reasons, I'm not even going to look at it. All right? Again, you are proving something. There is no, all of this is your answer. All of this is your answer. All right? So now let's take a look at B. Pick your side. What side are we going to work with, left or right? Left. And again, I kind of gave you a hint in number 1. Read out everything in terms of sine and cosine. So what's tangent going to be equal to? Tangent's going to be equal to what? Sine over cosine. And again, what's my reason? What formula did that come from? That came from my quotient. Reciprocal is when you use the top one.
Oh, okay.
So now what comes after I replace tangent with sine over cosine? What algebra can I next do? I can do what? Multiply. So I'm left with a what? Sine x. Am I done? What was your end goal? To get a sine x. So some of them are just a two-step, like this one. Okay? Let's take a look at C. What side's the more complicated side? Left. So that's the side I'm going to work on. Remember what your end goal is. Always keep your end in mind. Again, look at the numerator. I have a 1 and a cosine squared. So where do you think on your pink sheet we're going to be looking? Which formulas? Pythagorean. So looking on your pink sheet, or looking at your hexagon, you can also look at your hexagon. What is 1 minus cosine squared equal to? Sine squared. And again, my reason, again, you can abbreviate Pythagorean as long as I understand what it is. I just abbreviated P-Y-T-H-A-G, identity. Now what? What can I do with that fraction? Can I simplify that fraction? Yes. What's sine squared divided by sine x going to be? Sine x. Am I done? What was my end goal? Just get to sine x. Okay? Look at D. Yeah.
On tests, are we going to get like an hexagon and we're going to fill it out?
Yeah. Mm-hmm. Or you can just sketch one yourself. Doesn't have to be a pretty hexagon. I'll show you how you can hex them. Yeah. Look at D. What side looks more complicated? Right side. Where do you think you're going to start? Pythagorean identities, exactly, because you got a trig function squared and a 1. So what is tangent squared plus 1 equal to? Tangent squared plus 1 is equal to what? Secant squared. And again, look at 1 minus cosine squared. 1 minus cosine squared is what? Sine squared. And again, this is just your Pythagorean identities. What do you think you're going to do next? Yes. Again, remember where our goal is. We're trying to get to a tangent squared. So by my reciprocals, I know that secant squared is equal to 1 over cosine squared x. And again, that's just my reciprocal identities. Notice I'm not doing more than one operation in one step. So what's next after I did 1 over cosine squared times sine squared? Again, remember, sine squared has a denominator over 1. What would be my next step? What would I do with those two fractions? Multiply them. So sine squared x over cosine squared x. And I just multiplied. What is sine squared over cosine squared equal to? Tangent squared. What's my reason? Quotient. Okay? The big strategies that we're concentrating on is changing everything into sine and cosines and using those reciprocal, those Pythagorean identities. So let's look at A. What side looks like the more complicated side, the left or the right? Left. So, first of all, this is just a division problem, isn't it? Isn't there another way I could write division? I could rewrite it what? Instead of vertically, I could rewrite it what? Horizontally. So if you want to, let's just try and rewrite this. Tangent squared x divided by secant squared x. Well, when I divide fractions, what am I actually going to do with this secant squared? I'm going to end up doing what? Multiplying by the reciprocal. So again, you're just simply going to divide. What do you think your next step is going to be? Where are we trying to get to? We're trying to get to what? Sine squared. So what do you think we should try and do with this left-hand side? Change everything into what? Sines and cosines. So what's tangent squared equal to? Tangent squared is equal to what? Sine over cosine. What's 1 over secant squared equal to? Cosine squared. So again, I use my quotient identities and I use my reciprocal identity. What's next? I can cross out the cosine squares. And what am I left with? Sine squared. Simplifying, or you can say multiply. Okay?
The step before was
The quotient identity and the reciprocal identity.
and
Reciprocal.
simple.
Yeah. You guys go ahead and try B for me. Notice I can cross cancel those sine squares, which gives me 1 over cosine squared, which is my secant squared.
So that's what it says.
Yeah, we knew what the answer was. We knew we were trying to get to. The paths we may have taken may have been a little different, but it doesn't mean the way I did it was more correct than the way you did it. I already know, guys, I'm basically telling you what the answer is in the very beginning. That's why your work is your answer, just like when you guys had to construct proofs back in geometry. Your justifications and your work, that's your answer. You're proving something to me. You're proving why this fraction is equal to secant squared. And you're proving it through your work. That's why your work is your answer. I'm telling you the answer is secant squared. I'm telling you that this can be changed into secant squared. So that's why you're proving it to me. Go ahead and try the next one for me. Probably a little bit more. So guys, if you want to check my work here. Again, we know where we're trying to get to. Always keep an eye on where you're trying to get to. We're trying to get to a secant. And I know a secant is a 1 over cosine. So always keep an eye on the end goal. So your last 2 steps, knowing secant is a 1 over cosine, may kind of help springboard you on some of your steps. Again, try changing everything into sines and cosines. Yes, Mike?
So we can't do reciprocal identity.
No, you shouldn't. Yes,
I had 3 steps. Is that okay?
I'd have to look at it. I'll have to look at your work, but yeah. I mean, like I said, everybody may have something a little different. Doesn't mean that I'm more correct or anything. As long as you're showing me and justifying all of your work. Yes, you.
Yeah, my 2 steps were great.
Yep. Mm-hmm. Yes, Dylan.
So did you combine steps so for instead of having to do 2 steps to get 1 over sine theta or sine x and then sine over cosine?
If you combined it, yeah. I caution you on doing that because it happened with somebody other problem. They tried to change 2 and 1 and they realized that had I not changed the one thing, I would have been able to, because then they kind of got stuck because they changed something that they didn't need to change. So that's the only thing I caution you about doing that. You guys go ahead and try D for me. Yes, Milo.
Are you picky about the notation on a test or something?
What do you mean by notation?
With the line and number?
No, but you do need again, you should show me step 1 and make sure you number your justification with 1. Okay. So that way I know that this is your justification for step 1 and this is your justification for step 2. Okay? I always draw the line as a reminder that I don't cross the equal sign. In other words, that if I'm starting on the left, that's my line, I don't cross it. All right? Because that's where some students in the past have gotten in trouble. They try and work on both sides. When we get to more complicated ones later on, try and do D. Yeah, just make sure you're numbering your steps and showing me your work. All right, and for D, this is what you should have come up with. Again, this is what I got, 3 steps. Started by changing secant into 1 over cosine, and then you multiply, and then you have the quotient I need. Okay? So any questions on these? Like I said, we're spending